Relational database basics. The goal of this short video isn't to give you a complete database course, but more to give you the ability to discover by yourself what a database is and what advantage it brings. By the way, we'll be using a SQLite database to feed our lab model, so please practice a little bit in order to be confident once you will need to use it. We'll be using SQLite, as it requires no installation except a program to create or manipulate a database. Even if there is a bunch of software available, we'll be using DB browser for SQLite, as it is free to use and it has everything we need to manipulate data. We'll see what is a database and what is a database schema and how it can help to understand data. And I will try to provide you some example queries, some SQL query, from simple ones to more advanced ones. Here is a list of a few databases that you can download and play with it. So the Chinook database, which will be the one on which I will demonstrate some SQL queries. You have also the Northwind database, which is a sample database for Microsoft Access, which has been converted to SQLite, and for sure we will manipulate our OLAP database. Our OLAP dataset will be used to build dimension, so I will illustrate how to use it in planning analytics in order to feed dimension in another video. So what is a database? Basically it's a set of tables, and a table is a set of rows, and a row is a set of columns. So it can be seen as an Excel worksheet. You can also have within a database many other objects, such as indexes, which can help in order to query and find some specific record, triggers, which can help to automate specific processing. For example, when you delete a customer, it will delete all the orders for this customer, and some views, which are the result of SQL queries, which can be used as table. In order to query all the database, we will use SQL query, structured query language, and it is a specific structured language used to query database. So let's have an example on one of our databases. So let's discover the Chinook DB, the Chinook database. Chinook database is made of 13 tables: album, artists, customer, employee, etc., and a set of indices or indexes in order to accelerate, speed up all the querying. If I look at the album table, it has 3 fields, 3 columns: album ID, title ID, artist ID. And if I look at the artist table, you have the artist ID and the name. You can use browse data in order to see what is within each table, and I can use an SQL query in order to select all the rows from the table. So I will take albums, and you see that it returns all the rows from the album table. So if I want only to return one field, you just have to select which field I want to return. So I just have the title, and if I want to return only the album from a specific artist, so I will look at the artist table, I want only the album from AC/DC, so I will select title from album with a where clause, and I can see there is only 2 albums which is related to AC/DC. So what is a view? It's the result of an SQL query, which can be used and seen as a table. You can query a view as you query a table. It's useful if you don't want to write the same SQL query again and again. So it's an easy way to access data. So let's see an example. Actually, we don't have any views. We just have tables indices, and you see we don't have any views. So I will use the result of my SQL query and save it as a view. Save the result as a view. Save as a view, and I will say ACDC albums. The view has been created. So if I go in my database structure now, I've got a view which I can browse like any other table, and I can even query it as a table. You see it returns only the 2 rows. Let's have a look at the SQL code which has been used in order to create the view. Here is the SQL code. Drop view if exists main ACDC albums. So this will remove the view if the view already exists. And then you have a create view, name of the view as the result of the SQL query. Very easy to understand. Within a database, you can have several tables. You have album, artist, customer, employees, etc. And it may become quite hard to understand how each table relates to another. That's why we have database schema. So what is a database schema? It's a schema which helps you to understand how each table relates to another. So if I go to my album table, I can see that my album table has a link, has a relation with my artist table, and has also a relation with my tracks table. The line between 2 tables symbolizes a relationship. There is also a small icon, a small design at the end of each line. This design is called cardinality. So this is a symbol that you can find. 1, many, 1 and only 1, 0 or 1, 1 or many, 0 or many. So if I look back at my database schema, I can see that an album belongs to 1 and only 1 album, and an artist can have 0 to many albums, because there is a symbol of 0 to many. And the relation between tracks and album, an album can have 0 to many tracks, and a track can belong to 0 or 1 album. That's the way it is written. Finally, I will show you some queries which will use the most common SQL keywords used usually. So the inner join in order to merge information from 2 tables based on a common column, count records in order to count some records with some condition, group by to summarize information, subqueries in order to have a main query which use a subquery, and order to do some sorting. So let's get back to our Chinhook database and create a new tab in order to write some SQL. First thing, I will bring the artist ID. So I will have the title, the name of the artist, and the title will come from the albums table, and I will do a join on the artist table based on the artist ID, which is common for the 2 tables. So if I run this query, I can see I have got the title and the name. I can reverse it very easily, put the name first and the title after. And if I want to order, I can order like this. So I got all the ACDC. I can different to order by one, which is the number of the column, or by name, which is the name of the column. Same result. So if I order by title, I will have a different result. So if I want to filter now, I will remove this one, put back the title as it was and the name after. So if I take this query, got all the albums in the order of the album table, and for each album I've got the name of the artist. Prior to finish this video, let's make a quite more complicated query. Here is the query. So what we will do basically, we will count album by artist. So this is this subquery which will count artist. It will select the artist ID, count how many albums from the album table, and get the result. So if I run this subquery, I will see that ACDC, the artist ID number 1, has 2 albums, the second artist has 2 albums, etc., etc. The artist 22 has 14 albums, so if I want to see artist 22, who is it? 22 is Led Zeppelin, so for Led Zeppelin we've got 14 albums, etc., etc. Now I want to select the artist ID from this subquery for each artist which has more than 5 albums. So I've got only the 22, the 50, the 58, the 90, the 114, and 150. Now I want to select the title and the name, like our previous query, but only for the artist ID which are listed within this subquery. And I want to order it by name and by title. So I get the whole query, and here is the result. We've got Deep Purple, Iron Maiden, Led Zeppelin, Metallica, Ozzy Osbourne, and U2. So it's a complete example which shows you all the possibilities that you can have. If I want to have only those with 5 albums, I run my query, and with only Pearl Jam, which has only 5 albums. Thank you for watching. I hope you enjoyed this video.